because it's already there. And I change, this is the key, I change the index in the matrix from 1 to 2. This is the second curve. And look at the variability, even from 1920 to 1921, it is a different situation with low flows. Okay. Now, how to add the remaining 88 curves, not one by one, because it's too long. So we are learning now how to write cycles in R. I need to write a cycle. It's extremely simple. The instruction is for the cycle variable, let's say that it's I. Sorry. This is the correct instruction. For I in 390, you see that now R is expecting something more, because this instruction means, dear R, repeat what follows 88 times, and please adopt a variable called I, which is updated at each repetition. So the first repetition I is equal to 3, the last repetition I is equal to 90. So again, what is the message? Dear R, please repeat what follows 88 times by updating an index I each time you repeat. And the index I should vary between 3 and 90. And then R replies, okay, please tell me what I should repeat. Good. Now you can go back to the instruction lines. This is what R has to repeat. But be careful here. The index is not 2. The index is I. Done. Everybody is okay? No problems? Okay, very good. Very good. Now, we have about 10 minutes. We are not done, because now we have an idea of the variability, but we have to plot the average there. Not only the average, actually. We should plot the average plus a range of variability. But let's start with the average. And then, for the range of variability, I'll show you the instruction and I leave to you to complete the exercise at home. Okay, let's compute the average. And what do we have to do? You know, for each day, here you see the days. For each day, we have to compute the average flow. It is very simple. We have a matrix. We have to work on the index of the day and compute the average of the vector that corresponds to each day. And then we have to plot this vector here. Okay, so let's define a vector. Let's call it A VG. It's equal to, let's make a repetition of 0, 365. This is a case where the vector has to be created before computing the average. Because if you don't define a vector first, when you use it, it gives an error. I'll be more detailed in a second. So, for now, just assume that I created a vector, A VG, that is a sequence of zeros. Okay? And this is the instruction. Now, I can take a for cycle for E in 1, 365. And then I could say A VG I is equal to mean river flow to 1 comma. Okay, I computed my average. Oh, sorry. It was a mistake, not 1 comma, but I comma. Let me repeat it. I comma, okay? Because I'm working on first, second, third, fourth day. Now I have to plot this vector on the graph. Okay, let's plot the vector on the graph. Lines, sequence from 1, 365. The vector, and let's say line width equal 3, color equal red. Now there is something wrong here. I forgot a sort somewhere. Okay, that's fine. I mean, let's correct the mistake. Or not a sort, yeah, the vector, okay, let me think about it. Anyway, the graph would be fine, but it's the line that is not correct because I computed the average of of the observation each day, not the average of the flow duration curve. So this is something that needs to be corrected. Sorry for that. So when I computed this instruction, this is the average of the observations in each day, not the average of the flow duration curve. So this needs to be changed. Okay. The problem is that I didn't save any. I didn't save each flow duration curve, so it's a little bit complicated. Now let's go back to the file, okay, and let's see what I did here. Before we read on the file, let me make a premise. Today, we made, in our reference system, in our context, we made a big step forward because we learned how to write a program. And then at the end of the story, I forgot an important step, which is the sorting of the data. And now I want to read with you what is the correct sequence. We are not going to apply each of the lines here now. I just want to discuss with you in 5 minutes these instructions, so to give you the means, the basis for applying them at home. More than applying, understanding, because applying is very easy. You just cut and paste, okay? But you have to understand what you're doing. As I said, we made a big step forward, and maybe that for some of you this was an easy step, because some of you probably already know how to program a PC. For other of you, maybe that the step was a little bit tougher, because some of you probably don't have a long experience in programming. The message that I want to give you is that this step that we did today is extremely important. You have to learn how to write a program on the computer. And the program depends on the language that you're using, but once that you learn one language, it's extremely simple to transfer to one language to another. So now we are referring to the R language, which is very similar to the MATLAB language, which is very similar to the Fortran language, whatever. So what's important is to learn the concept of vector, matrix, need to define a vector before using it, and in this case I needed to define it because otherwise when you compute the average inside the 4th cycle, it gives an error. 4 cycles, an extremely important step. Conditions, we didn't talk about conditions yet, we will talk about conditions later. This is extremely important. As I said, you may think that you don't need to learn how to program because there are a lot of commercial programs today available. I tell you that that's not true. You need how to program, how to write a program, because this is a skill that is extremely useful, because sometimes you don't have a commercial program at hand. You need to write your own program. Even if you have the commercial program, it may be quicker to write your own program, but it is quick if you learn how to program. And this is extremely important for your CV. Who looks for engineers to enroll, to give a job? He's interested in the commercial programs that the engineer can use, like AutoCAD, etc. But I tell you, it is also extremely interested in getting a person that uses the PC how we use the smartphone. Okay, so you are very. If during an interview you can prove that the PC for you is you can do whatever you want with the PC, this is a very strong point in your CV. And you are still in time to get whatever skills you want, but it's important that you take advantage from your studies, from your study period, because later on it becomes more difficult. Okay, let's look at what I did here. So, first of all, what I did, after creating the array, I sorted it. You see that after creating the array, I sorted it. In my exercise done now, I sorted each time when computing, when plotting the curves. It is more useful in this case to sort the matrix, okay, because you have already into the matrix the flow duration curves. I'm not, I'm not assuming that you are understanding everything now. It's just enough that you understand the basis, and then I invite you to run this instruction at home if you wanna, improve your skills. Okay, and then RiverFlow 2 is the matrix of the already sorted data, so it's the matrix of the flow duration curve. Now, here I computed the average, and I computed the average of the sorted matrix, which is fine, because the index I now identifies the first duration, 1, 2, 3. So I am computing the average of the flow in each year with the lowest duration, which is fine. It is rightly what I want to get. Okay. Now, here there is a comment. Let me see. I don't understand properly. Yeah. Okay. This is commented. You have to uncomment it if you want to plot this graph. And here there is a nice instruction with the average. Keep in mind that here there is an alternative. You may plot all the flow duration curve with different colors by using another instruction, matplot. Here it's commented. If you want to try it, you have to uncomment it. Okay? And here the same thing. Here the plot instruction is commented because the plot is already there. And if you don't have the plot already there, you have to uncomment it, of course. Now, what's done here is to compute a range around the flow duration curves. Do you remember that I said you can exclude the higher 5, the highest 5, and the lowest 5 in order to identify a probability range, a frequency range, okay? This is what is done here. If you exclude the highest 5 and the lowest 5, you get a 90% range. Okay, let me say. Let's assume that we have 100 curves, not 90. If you exclude the highest 5 and the lowest 5, you get the 90% range, okay? Of course, we don't have 100 curves, so we have 90. Okay, one may say exclude the highest 4 and the lowest 4, but a more refined way of doing that is to compute the standard deviation of the curves for each duration. Then, when I plot the average, I also plot a line for average plus standard deviation and a line for average minus standard deviation. It can be proved that within the interval average plus standard deviation, average minus standard deviation, you have 68% range. It can be proved. We don't prove it. But there is a proof in statistics that says that average plus sigma, average minus sigma, is a range that includes 68% of the observations. If you want to get a 90%, you have to enlarge, widen the range. And then what's done here is matplot, plots all the flow duration curves, plots the average, and plots the range. And look at the colors that are different. What comes out is nice. Let me just show you. Because in order to get it, I just have to make a cut and paste. Should work. Not really sure because there is a decreasing. Let me try. Yeah, it worked. Here is the result. So you see here all the curves and the 68% range with average. This is what we wanted to obtain. It's not very clear. I mean, in order to get it very clear, one should not plot the individual curves, but only the blue and red one. But still, you can see what is the result. Okay, that's it.